Okay, we're going to go ahead and look at the 5 types of chemical reactions, the same ones that you guys looked at yesterday in class. And hopefully today I just reinforce or tweak a few of the details that you may have missed yesterday, or for some of you, maybe everything I say today just confirms what you did discover yesterday. So once again, our goal is just to identify the type of reactions by looking at them. We will worry about this, the predicting piece, after Christmas break. So once again, you're going to see me somewhat fly through these notes and skip a good bulk of it for that reason. So we're going to go ahead and start with our first type of reaction, the combustion reaction. And hopefully at this point you know it's when an element or a compound reacts with oxygen, producing energy in some form of heat and light. For it to be a combustion reaction, you must see the O2 present to burn, and you must see the CO2 and the H2O as products. You will always see some type of CH compound to start the reaction off on the reactant side of the equation. So with that, we're going to go ahead and jump right to our second type of reaction, and that is reaction number 2, which is your synthesis reaction. These are also called combination reactions, and just like I heard many of you say yesterday, it's when you have multiple substances reacting to form a single substance. And you can see that right in my example here. You have multiple substances reacting to form a single substance. An easy way to remember this is to look for one product. You see one product, synthesis. Once again, these 5 patterns don't even look at yet. We'll get there after Christmas break. I'm going to have you guys turn to our third type of reaction, and that is your decomposition reaction. And once again, like I heard many of you say yesterday, you have a single compound breaking down into multiple products. And to do this, it does require some type of energy, whether in the form of heat, light, or electricity. And in my example, there it is. You have a single reactant breaking down to form multiple products. An easy way to remember this is one reactant. You see one reactant, you know it's a decomposition reactant. And then once again, do not worry about the 5 patterns now. We'll worry about that after Christmas break. And then we're going to go ahead to our 4th type, which is a single replacement. And single meaning one. So there's the buzzword. You have one element replacing another element in a compound. And if you look at my example, there's this one element, it's the single guy, as I like to say, who will kick out a guy that's already in a compound. So in this case, Mr. B gets kicked out of the compound, and if you notice, he's all by himself. And now A has joined up with X. So we had one move, A kicking out B. An easy way to identify it is you're always going to have some element plus a compound gives you some element plus a compound. If you see that pattern, it's single replacement. Keep in mind, it could say compound plus element gets you compound plus element. The order doesn't matter. If you look at my example, here's my single guy, and it's a metal, and a metal can only kick out a metal. So he will kick out Mr. Silver, and poor Silver. He's now all by himself, and copper has joined forces with nitrate. Single replacement. And then lastly, if you guys can turn to your double replacement, reaction number 5. Double meaning 2. So you have an exchange of ions taking place. And how I like to teach it, it's always your outer atoms, so A and D, are going to join up, as you can see over here, and your inner atoms are going to join up, as you see over here, C with B. If you look at my real reaction here, same thing. Your outer atoms, so copper with phosphate, are going to join up. And then your inner atoms, chlorine with sodium, are going to join up. And there they are. There's my inner atoms that now made a new compound, and there's those outer atoms that made a new compound. A nice way to identify these guys is you have all compounds. So compound plus compound gets you compound plus compound. And that is it. So what I'd like you to do is go ahead and turn to the last two slides for a quick little recap here. And remember how to identify. So a couple words or less. If it's synthesis, you're going to see one product. If it's decomposition, you're going to see one reactant. If it's single replacement, you're going to see element plus compound gets you element plus compound. And if you have a double replacement, it's all compounds that you'll see. And then lastly, combustion, you're going to see some carbon-hydrogen compound plus your O2 is going to get you carbon dioxide plus your water. Okay, so hopefully that fine-tunes or reinforces or tweaks what you discovered yesterday, and now hopefully you can complete worksheet 3 in your homework packet.